Okay, welcome to the third part of the Goldratt simulator training video. In the previous video, we had discussed about the allocation of resources to different process levels, the way in which we can calculate how much of a particular raw material do we need to serve the process, the possible penalties that we may incur by deallocating a resource from one location and allocating it somewhere else. So with all those things in mind, now next we should be talking about how to run the simulation and what are the philosophies that we can adopt to run this. Okay, so I'm going to talk about two ways of looking at this problem. Neither one is the right way, or neither one is the wrong way either. It's just that I believe that one of these two ways, or any of these two ways, is going to give you some positive results. Is it the most optimal result? Probably not. Probably there are better ways that I'm not aware of, or there might be worse ways also. But nevertheless, the idea is to discuss these two ways of looking at the problem and see if it works for us. If it does, then very good. If it doesn't, then come up with something else. So it's up to you if you want to use the same ones that I'm going to talk about, or if you want to come with something of your own. Okay, now let's look at this problem. What do we understand from the layout that has been given to us? We know that we have to produce three items, three products, product 1, product 2, and product 3. We know that we need 4 input raw materials to produce these 3 different kind of products. Let's call them input material A, input material C, E, and F, simply because the alphabetic identifier is such. Okay, so I need 4 input materials. I've already purchased them. I've already given 65 to this guy and this guy, 35 to here and 30 to here. So I'm done with my purchasing part. Now what is remaining? Well, let's take a look. Out of these 3 products, you can easily see that product 3 is the one that seems to be having the least amount of dependencies, because it has its own independent line. It's not depending upon any one of those other lines. Meaning, if we can allocate the correct resources to it at correct time, then it can very well start producing items real quick, and we can sell them and we can start increasing our cash amount here. Okay, so what does it need? Let's go step by step. The first step, I believe, is to look, do we have any pre-existing processed units available to us? In case of product 3, the answer is yes, because we can clearly see that in this interim holding location, this rectangle over here, I have 10 units of work already produced and ready for me. In total, I have to produce 40, out of which 10 are already available to me. So naturally, I had to buy 30 more to make it whole. But nevertheless, I have 10 ready with me. Now for these 10 to reach the next stage, and for them to reach the next stage, and for them to reach the final stage of selling, I need to deploy the resources. Now what kind of resources do I need? So from this location, which is, let's call it F4, to F6, this location, I have a dependency on a blue resource. So let's take a call and deploy the blue resource over here. What will happen when I start my simulation is that this blue resource is going to take 15 minutes to set itself up. Remember, we had discussed about the setup time. If you've forgotten about it, you can go back to either part 1 or part 2, and I discuss about the setup time in both of them. So it's going to take 15 units of time to set itself up, and then it will take 1 unit of work that is available at this interim storage, process it, and send it over here. So we will start seeing this 0 that is appearing over here increasing. What next? From here to here, we have a dependency on a magenta resource. So let's do the right thing. Click on the magenta resource, drag it and drop it on this location. And now you can see that I have a resource allocated here, and as soon as I have one resource, one unit of work being processed by this blue guy and sent over here, this guy is going to pick up and he's going to start producing. He's going to start processing that item. Finally, to make a sale out of it, I'm going to have to deploy a cyan resource. Now, luckily I have two cyan resources, so let me take one and put over here. Now, in this way, we can easily see that these 10 units that we had, the pre-existing units of work that we had, we can start selling them without having to process any newly purchased raw material. So this raw material can lie over here. I will come back to why I'm not deploying a green resource here a little later, but I just want you to understand that these 10 units that were available to me are getting processed from time t0, that is from the time I start the simulation, and they will start to get sold. Meaning that I will have a productive revenue generating production line working for me as quick as possible. Now, what are the other possibilities that we could have considered? We could have considered allocating a green resource to this guy. What would that have meant? Remember, we have only 2 green resources and we have a total requirement of 4 greens. Okay, so if I'm going to put a green over here, that means one of these guys will not get a green. Now, if one of these guys does not get a green, that means this brown is useless because he needs a unit from both A and C to produce something of B over here, right? So I have to put 2 greens at the start of my simulation for this guy to be productive. But instead, if I put one over here, then I'm going to be left with only 1 green resource over here, and this guy will be starving, or the vice versa. This guy will be working and this guy will be starving, which is not optimal. Why it is not optimal? Because even without allocating a resource over here, I can start selling something off this line, and at the same time, I can start producing something from both A and C so that I can get to this level of B. Okay, so that's the decision we have to take. That how do we optimize those lines, right? So going by that philosophy, now we can take these greens and we can allocate them over here. Okay, now we got greens. So what will happen when I click on this button over here is that it will start setting itself up. It's a long setup process. It takes 120 units of time, so it's going to take a long time to start. So we have to be careful to have them allocated well in advance in time so that they set up quick and they start producing. And the next thing that we need to take care of is to see what do we do with this E line. Okay, if we come to this E line, you will see that the immediate requirement is for a cyan resource. Now I have a cyan resource available to me. I had 2. One has been deployed to the F line to make the sale happen quick, and the other was available, so I put it over here. So now this E, 35 units of E that I had here, they can start getting processed as soon as I start my simulation. Okay. What else do I need to make a sale happen here? I need a magenta. I do have a magenta available to me, so I'm going to put a magenta. And then finally, I am going to need a brown because I have a brown available and I have a need of a brown here, so I can put it over here. Okay, so now I'm all set up, but let's understand that how is this whole thing going to work. Okay, the first thing you have to notice is that we have one critical resource, one resource that is going to bottleneck us in this particular model, and that resource is the blue resource. We have only one of it, and we have a requirement of 3. And all these 3, if you see, they're at the same level. That means at some point in time, we will have to juggle the blue guy between these 3 levels to keep all the 2 production lines running. And that is going to be a real tough proposition. Again, if you take another look, this E line, the blue resource in the E line, is going to take 28 units of time to produce 1 unit of processed work. And over here, again, we need a blue, but this blue is taking only 6 units of time. So it is almost 5 times as expensive. Now, this is something that we have to be a little concerned about, because what is going to happen is, if I do not get something over here and something over here, this will be useless. I need 1 unit of this and 1 unit of that to get 1 unit of this. So, and this is really, really slow. So, before I start processing anything on the C line, which is this line, I need to make sure that I have some buffer amount available here. I need to create a buffer here. Okay, so this is the way I'm going to take, that I will create buffer quantities at the critical lines, and then deploy the resources in such a way that the production is optimized. Now, if you remember, I had allocated the only blue resource available to me to the F line. You may ask, why have I not put it to the E line to begin with? That is because this blue can start processing the units of work straight away, because it has 10 available to it from pre-existing store. Whereas this blue has to wait. It has to wait for this cyan and this magenta before to process 1 unit of work before it can be gainfully employed. So there is no use in putting the blue over here at this point. I will wait until at least a few units of E are processed, and then I can start producing. There is another way of looking at it. Okay, I had missed this actually. So there are actually 15 pre-processed units of E available here. So yeah, I must correct myself. If I put the blue over here, it's actually going to start some productions happen. But then I have to see that what is this guy dependent upon, because I may have a unit here, but until I have a unit here, this guy is useless. So this guy is again dependent upon A and C, and A and C are dependent upon green. The processing agents are green, and these have really long setup times. It's like 120 units of time. So first of all, this is going to take 120 minutes to start these green resources here. Then they are going to take some time to produce units. Then this brown guy, the brown guy is pretty fast actually. He doesn't take any, he doesn't need any setup time. It's 0. So he can start producing as soon as he gets 1 unit of work here. But nevertheless, it's going to take 8 units of time for it to process one unit from here. Okay, so even if I were to put the blue over here, it is probably not going to be that useful, because this blue will again be starving. So well, it's a really confusing kind of layout, because there are too many dependencies and there is not too much you can do because of the resource dependencies, or the resource constraints rather, not the resource dependency, the resource constraints. So we have to be careful with the blue. That's what I wanted to convey in this entire piece that we discussed. Okay, another thing that is of some importance to notice at this point is that you see, wherever we have deployed a resource, the sign changes. It's showing as +4 or +5. So this plus means that a resource has been allocated to it. Whereas this guy over here, it just shows the number. It doesn't show a plus sign. So that means it does not have any resource allocated to it. If you want to allocate the resource, you need to drag it and drop it. You can do that. So you may at some point in time feel that although this guy is producing, but this green resource probably would be more useful here than here to make a sale happen. So you can just drag A1 and send and drop it over here. Okay, that is also a window that we should probably discuss about, but not for the purpose of this discussion. So you can drop it over here and it will set itself up for 120 units of time and then start producing. Okay, so we discussed about how to set things up and what is the philosophy we are going to take. So first philosophy is fill things up layer by layer, make them happen, and then and the second philosophy is make whichever line is going to be the quickest to produce work. Let's not uh,